Operating system. We will begin this course with a high-level introduction to operating systems. The operating system acts as a platform of information exchange between your computer hardware and the application running on it. Most people are familiar with the Windows operating system family like Windows 10 XP and Vista, or Apple suite for operating system like Catalina, Mojave, and Sierra. But for a purpose of this course, we'll focus on Unix, the open source OS deployed all over the world in both personal and commercial systems. We will start with a discussion on some of the earliest operating systems, including those which are considered a precursor to the operating system that we are familiar with today. Then we'll review the general OS structure and give a basic functional overview. We'll conclude this module with a discussion of modern operating system and devices, the process and the threads. We'll discuss two central building blocks of modern operating system: process and the threads. Process, instance of a running computer program, and threads, specific task running within a program, are integral to the understanding of how an OS execute a program and communicate of information between each of the computer architecture layer. Synchronization. Because of a number of different entities will need to access data, it's important to learn how to maintain a consistent view of data across the OS. This is why we need a good synchronization management system. We will begin this section with an overview of why synchronization is so important to an operating system and the problem that could arise if synchronization is not handled properly. CPU scheduling. Central process units schedule deals with having more processes threads than processor to handle those tasks, meaning how to CPU determine which job it's going to handle in what order. A good understanding of how the CPU scheduling algorithm works is essential to understanding how an operating system works. Deadlock is a paralyzing process state resulting from improper CPU scheduling, process management, and synchronization management. During this time, processes are blocked as they compete for system resources or only communicate with each other. It can't be guaranteed that deadlock may be avoided 70% of the time. It's important to know how to avoid the deadlock state and how to recover from it. Memory management. Memory is the oil that keeps the computer running smoothly. It's present in various forms throughout the entire computer system. As software developer, it's absolutely essential to have a solid understanding of the role of memory play so that you are able to efficiently use memory in your program, as well as understanding what's going on under the hood should a problem arise. We will discuss the role of memory in the operating system. First, with an overview of the memory hierarchy and how memory and OS interact with each other. Thank you for joining me, and see you inside the course. Thanks.